So we will talk about the fundamentals of petroleum economics today. So as you see, we have small pass here from introduction to some risks, and we will end up with Dutch disease. So before starting our small journey, let's take a look at our agenda, what we're going to talk about today. So we will know some introduction about petroleum economics, economy and petroleum, and we will see some statistics. It will be world statistics, and I will give you some Azerbaijan statistics, but of course, if you want, after the webinar, you can search your country. I hope many countries will be there. And secondly, we will look at life cycle of petroleum project, and you will see some economic decisions. At the end, we will end up with risks. Several risks we'll talk about, and the case of Dutch disease. So if you're ready, we can start, I guess. So in general, we all form the economy. You, me, my parents, your friends, we all form the economy. If you work, if you study, even if you go to supermarket and buy some food, you form the economy. How is this happening? Just imagine you go to a bakery and buy bread. Hundreds of people just like you demand bread, right? If there is demand for bread, there should be a producer and supplier of bread. So in order to produce bread, bakery man needs flour, salt, water. In order to produce flour, wheat is needed. How we can produce wheat? For this, we need land and workers. Can you see, just with a small bread, we need huge economy. We need workers, we need land, we need different commodities and food. So here we can see that all we form the economy, because economy is about production and consumption, and how government can deliver all production, all scarce resource to the society. So this is about the economy. That's why we form the economy. And it's really, really hard to imagine economy without petroleum. Just imagine this morning, I don't know where you are, maybe you just start your day, but it's 4 p.m. in Azerbaijan. So just imagine you start your day, you get out of your bed. So except scrolling your Instagram and Facebook, you need to do breakfast, right? In order to make your breakfast, you need oil and gas, like you need to, for example, heat your water. For this, you use oil burning station or gas burning station. So when you make your breakfast, you have to go to your work or your school. Just ignore the fact there is pandemic. Just imagine there's no pandemic. We all go to work or school. So for this, you need bus or car. And as you know, bus and car are working with petroleum. So even in order to start your day, you need petroleum. All we need petroleum. So if you don't start your day, you cannot contribute to economy. You cannot produce. You cannot consume. So that's why it's really hard to imagine economy without petroleum. And in general, we can understand petroleum is a mechanical power. Like in order to run businesses, in order to run machines, petroleum is needed, right? And also we can understand petroleum as political power. If you look at the history, we can see that some battles and wars were happened because of petroleum. So we can see Azerbaijani case also. In Soviet Union time, Russia and other Soviet countries, we can say that they need Azerbaijan petroleum. So that's why we can see some battles, wars because of petroleum. And also we can see this kind of political instability Middle East. So that's why we can understand petroleum is a power. But in order to understand petroleum, we have to know about economy, right? Petroleum economics, or we can call petroleum business. We have to take advantage from development in petroleum. So that's why we need to understand petroleum economics, or we can say petroleum business. Why I say this is petroleum business? Because mainly we will talk about petroleum investment or petroleum life cycle project. This is important for petroleum economics. So before starting petroleum business or petroleum economics, let's take a look some statistics about petroleum. So there are two statistics, as I said, I already clicked that. So first, about world statistics. So energy production and consumption in terms of world. So there are many graphs here. I don't want to waste your time. We just look at some important graphs here and charts. So first one is about how much energy does the world consume. So this is the primary energy consumption by source. So if you look at, let's say, the beginning of 20th century, we can see that coal was a leader. A traditional biomass and coal was a leader in order to consume energy. But when time passes, we can see that here in 2019, the recent data, oil is a leader in order to consume energy. Then coal and gas follow oil. We can see renewable energies here, but as you see, it's not too much. Hydropower is a leader among renewable energies. If you would like to look at relative energy consumption, just click here. We can look at the relatively, so percentage. Again, as you see, oil takes 31% from all energy consumption. If we go forward, we can see coal 25 or 26, we can say, gas 22, hydropower 6, etc. So this is the recent data about energy consumption by source. So here you can see oil, gas, which we can call them petroleum or just fossil fuel. They're really important because they take big portion of energy consumption. So that's why we need to know about petroleum. We need to know about petroleum economics. So let's take a look at other charts. Like I like this one. This is map. Where do you consume the most energy? So if you look at this graph, of course, dark red means there's most energy consumption. So here we can see United States, Canada, Saudi Arabia, and some neighboring countries consume the most energy. But why there is difference across countries? The first reason is about population. So it's saying that if a country has a lot of population, it means that their energy consumption will be more because more people means more energy consumption. But you can ask such kind of question. As we know, China and India are two most populated countries in the world, but they don't have dark red. So let's imagine India here. You can see right in the map. So in here we can see in India approximately energy consumption is 5 kilowatt hours, right? 5 million, I think, kilowatt hours. So, but India is most populated country, one of the most populated country in the world. The reason is about inequality, is about economic inequality. Like in India, rich are very rich and poor are very poor. So it means that there's an inequality between one person to another person. And these poor people cannot afford consume oil, gas, I don't know, other fossil fuels. They mainly use traditional ways like wood, forest, wood, or other organic matters. They mainly use such kind of energy, but these energies, unfortunately, are not quantified exactly. So the world cannot quantify such kind of energy. So that's why here you can see there is a low level of energy consumption, but actually it's more than this. But according to this data, it's all about the consumption of fossil fuels or renewable energies. So another example about consumption. So this is, I think electricity doesn't, we don't need electricity here. Maybe we can look at an Azerbaijani case. So here is about annual change in primary energy consumption. Again, you can just look at the countries and you can see the growth here. This is about the rate. What will happen in 2020, for example, we can see in Canada from 2018 to 2019, energy consumption decreased by approximately by 1%, or exactly we can say 0.94. So it decreases. But we can see, for example, in Saudi Arabia, from 2018 to 2019, the energy consumption increased by 1.70%. Other thing I would like to show you, I think I found it here. Yes, this is the per capita electricity consumption. Okay, let's look at electricity consumption here. Again, dark blue means there is much more electricity consumption, and as you know, electricity doesn't mean energy. Energy doesn't mean electricity, sorry, but electricity is a part of the energy. So we get electricity from oil station or gas station or coal station, even renewable energies like wind, hydropower. So here we can see that per capita electricity consumption here in United States, in Canada and northern countries, it's a little bit more. The reason is like that. As we know, in northern countries, winter is very, very cold. So they need heating like us. But in order to heat themselves, they need much more electricity. So that's why we can say per capita electricity consumption is high in those countries. And if you look at the days of year, we can see in some cases the nights are longer than days, so that's why they need lighting and they need electricity. So that's why per capita electricity consumption is higher in those countries. So this is about the world data, but as I said, you can look at other graphs by yourselves. Now we can look at energy country profile, single country. I chose Azerbaijan, but you can choose any country. As I said, I think most countries are here. So we're interested in this. I think if I hope I can find, no, it's not here. It's about the energy consumption by source. You can see huge difference. Yeah, here. So this is the energy consumption. It's loading. Yeah, this is the energy consumption by source in Azerbaijan. So what we saw in world data, we saw that oil is a leader, then coal, follow oil, then gas. And hydropower is a leader among renewable energies. They have some portion. But here, if you look at Azerbaijan case and recent data, we can see that in 2019, in our case, we don't have much coal energy. Yes, we use coal for energy consumption, but it's less than 1 terawatt per hour. In our case, gas is a leader for energy consumption. Then oil, follow gas. If you look at renewable energies, it's not too much, but hydropower is a leader, 4 terawatt per hour. So here, this is the proof that petroleum is really important in Azerbaijan because we use them a lot. If you look at other graphs, my favorite, so this is the share of primary energy from fossil fuels. Fossil fuels, as you know, is coal, oil, gas. In general, we can say petroleum. This is about the fossil fuel, and if you look at the data in 2019, we can see a huge amount, right? 97.52% comes from fossil fuels, comes from coal, oil, and gas. We can ignore coal because it's less than 1 terawatt hours. We can look at oil and gas, which is huge amount. If we would like to compare some other country, there's an add country here. So let's compare with Norway. See, there's a huge difference between them. If you look at in 2019 data in Norway, we can see that just, let's say, 33% primary energy comes from fossil fuels. If we compare with Azerbaijan, this amount is small. Why? Because Norway mainly takes care of renewable energies, especially hydropower. You see the many seas and rivers in Norway, so hydropower energy is kind of easier for them. And hydropower is not only leader in renewable energies, it's also leader among all energies, renewable and non-renewable. But if you look at the Azerbaijan case, our leader is gas and oil. So you can see proof here, like share of primary energy from low carbon sources. Low carbon sources means nuclear and renewable sources. So we don't have a nuclear energy, so that's why we talk about renewable sources according to 2019. So here we can see just 2.48% produces low carbon sources. It means hydropower, wind, solar, and I think we don't need. I think that's enough about this statistic. So we don't have nuclear energy in until 2019. I don't know what will happen next. So this is about statistics. Again, you can go into this website and you can just find your country. There are many graphs and statistics here. It's fun, I guess. So I think we can continue. Yeah, so guys, now we can start with petroleum business, some economic decisions. So if you're petroleum engineer students, I think you know already about this, but I would like to mention once again, maybe you know better than me, but maybe some of you don't have any information, so we can look at. This is the life cycle of upstream project in petroleum industry. So this, you can see 4 steps. Actually, there are 5 steps. I will talk about the last step. But we will start with explore phase or exploration step. What does it mean? So imagine you're an investor and you would like to invest some petroleum project. So firstly, you have to do some surveys. This survey is about geological surveys that you would like to make sure that if I try to find petroleum, will I be successful or not? So that's why you have to make some geological surveys. So you collect some information, some data that, for example, in this area, in this land, there's a potential reserve or probable reserve according to surveys, according to geological data. Then you have to do your first drilling. This is called exploration drilling. So after your first drilling, you can see, yeah, my data was right and there's some reserve here, petroleum reserve. Then you can estimate other potential reserve. But you have to be careful about here, because potential reserve doesn't mean it's proven reserve. So proven reserve is different, potential reserve is different, probable reserve is different. But you can estimate. This is your prediction, your estimation. After exploration, you have to appraise. Appraise means you have to evaluate your petroleum, your finding. So that's why you use your second drilling. This is appraisal drilling. So you evaluate your petroleum. And you have to generate some economic and environmental plan that, for example, when I should start, how should I transport this petroleum with pipeline or with tracking, such kind of economic and some environmental plan that I have to be care about the environment, that I have to I don't have to hurt the environment, because I would like to produce this petroleum a very long period of time, so I have to be careful. So this is evaluation, this is appraisal. After this, you need to develop your petroleum. So what's left? you have to drill the rest of your well, and you have to build surface facilities. It could be petroleum sites. It could be petroleum transportation, like pipeline tracking. You build, you develop your resources. Then you're ready to produce because you explored, you appraise and develop. Now you're ready to produce petroleum. So firstly, you have to extract, right? After extraction, you have to transportate your petroleum, and you have to think about your production management. Will you produce something from crude oil, or will you just export your crude oil to foreign countries? How many barrels oil you have to produce for one day? This is not just random numbers. You have to really think about it. You have to really do research about the production, because there's an economic limit. If you produce more than this or less than this, maybe you cannot get benefits. So in order to get benefit, you have to care about your production. So you have to manage your production. So here, when you start your investment, you have to care about your money, right? Because in the beginning, you will not earn anything. Just let's start from the beginning. The first step, first phase, explore. For this, you need to spend your money. You invest. You found high-skilled laborers. You found high technology. So you buy something. You spend your money. What's left in your hand? Nothing. Even negative number, because this is your investment. You don't earn anything. In the second phase, again, you don't have anything, because you evaluate your petroleum. You generate some plan. You use drilling. You use well. So again, you don't have anything. In development phase, I'm sorry, but you don't have anything, because again, you have to build surface facilities, you have to invest, and you have to prepare yourself for production. In the production, maybe in the first year of production, again, you will have negative earning because you just started. Maybe your cost means expenditure, expenses, is more than your benefit, more than your earning. But you expected that after some years, you will earn some positive number. You will get money, you will make money. But for this, you have to make a good prediction about future. So now we can look at some economic decision about earning, and we call this earning cash flow. So you can know cash flow is. So net cash flow, or we can say cash flow, doesn't matter. It equals to cash inflow minus cash outflow. You can understand from the name. Cash inflow means that you receive cash. How you can receive cash? Of course, if you sell your product. Your product is petroleum, right? When you sell product, you receive cash. This is your cash inflow. You have to subtract your expenditure and your cost. It could be tax or royalties. I don't want to talk about the tax and royalties. Just imagine, for simplicity, it's just cost. So this is a cash outflow. It's going out. So this is the amount you paid. So that's why it's called cash outflow. For simplicity, we say this is just sales of product and minus cost. So as we understand from the our steps, 4 steps, in the first 3 steps, we don't have any earnings, so our cash flow will be negative because this is investment. But in the production, we expected to earn some money. And we expect our production phase will last longer. But unfortunately, after some period of time, you expected that your petroleum project will end, because as we know, petroleum is a non-renewable energy. So, but until it finishes, you have to care about your cash flows. So that's why you have to predict, you have to expect true net cash flow, that you will think whether I should start this investment or not. So for this, we need to know that money has time value. What does it mean? Maybe you're familiar with this phenomena that Time is money. It literally is money in terms of economy. So now I would like to ask some small questions, but don't worry, I just would like to know your opinion. So if you agree with me, you just please raise your hand. I won't ask anything. I know maybe some of you are afraid of this. I really know your opinion about these offers. So imagine one person came to you and say, I have 100 manat today. So for foreigners, manat is Azerbaijan currency. So they say, I have 100 manats today. You would like to give this, take this 100 manat today, or if you want, we can wait for a year. After 1 year, I will give you exactly this 100 manats. So I'm asking for you, will you agree to take 100 manats today? So just raise your hand, and I would like to know your opinion. Would you like to take 100 manats now? Okay, if you ask me, I will take now, and I will explain later. So, okay, second one I think is easier, right? 100 manats today or 10,000 manats after a year. Would you like to take 1,000 manats after a year? If you agree, you can raise your hand. Great. I am totally agree with you, Nurana, because it's really good, right, to wait just for 1 year and take 10,000 manats. So thank you. And the last one is, last offer is like that, 100 manats today or 140 manats after a year. So maybe this is kind of complicated. Maybe you're in difference and you say, okay, 1 year additional 40 manats, should I take or not? So now we will explain which opinion is better. So here, before starting, I would like to say the time value of the money you have now is not the same exact amount as it will be years from now. It means that 100 manats today is much more valuable 100 manats after a year. This makes sense because that person can give you 100 manats today and you can make investment and you can earn some return from this investment. And this, when you earn something from this investment, then you can see, yeah, taking 100 manats is much better taking 100 manats after a year. So 100 manats today is not the same 100 manats after a year. So when time passes, money lose its value. As I said, you can invest right now, so that's why it will be better if you take money right now. So you can see one example, then you will understand better. But firstly, I would like to tell present value and future value. I'm sorry, I forgot it. So it means that money has two values, present value and future value. You can understand from the names. Present value means that the value of money today. Future value means that value of money in the future. It could be after a year, after 10 years, after 6 months. So that's why we have to care about present value. We have to calculate present value of all money, that if we would like to compare money. So now we can look at the example. So imagine you have 100 manats. So in the first case, as I said, I will accept 100 manats and I accept it. And I'm going to invest my 100 manats, which is my present value, today's value of money. So for simplicity, let's say I go to bank. I wouldn't do that, but let's say I go to bank and I deposit my 100 manats and they say our interest rate, which you will earn extra, is 40% per year. It could be per month, per quarter, but for simplicity, let it be per year. So I say, okay, I'm waiting for 1 year and then I came back, I will take my money. And after 1 year, I will receive 140 manats, which is the future value. How can I calculate it? So today you have 100 manats. and you go to bank and put deposit, they say you will have 100 manats. This is your money, but you will earn additional money, which is interest, and this interest is 40% from your present value. So this 100 manats is mine, but this percent is what I earn. This is interest. So 100 manats, which is mine, multiply 0.4 or 40%, which is interest. So for simplicity, we can write like that: 100 multiply 1 plus 0.4, and it will be 140 manats. So it means that 100 manats is 140 manats for me if I invest. So if you come back to our first open, 100 manats today and 100 manats after a year, according to our example, if interest rate is 40 manats, I would like to take 100 manats today, because I know that if I take 100 manats today, I can go to bank and after a year I will have 140 manats instead of 100 manats. So that's why if you compare these two, we can see that to get 100 manats today is much more beneficial. If you look at here, actually it doesn't make sense to take 100 manats today, because if we take 100 manats today and if we go to same bank, they will offer 40% and we will receive 140 manats after 1 year, and we can see that 140 manats is less than 10,000 manats. So that's why we prefer to wait, and after 1 year that person will give us 10,000 manats. But if you look at the third case, so that person says to you, 100 manats today, or we can wait, and after 1 year I will give you 140 manats. And you will think, you just go to bank and bank says we offer you 40%, and you say, okay, if I take 100 manats today, if I go to bank and after 1 year I will receive 140 manats exactly. This is the same amount that person offered me. So that's why you're indifferent. You will say, it doesn't matter for me. There's no difference for me. I mean, in case I will get 140 months after a year. So the decision is up to you. Probably you will not go to bank because there's a transportation cost or something. But if you just think about transportation cost, means bus, car, this cost is zero, then you're indifferent, taking money today or taking money after a year. So that's why we have a magical formula here in order to calculate future value. FV stands for future value, and PV stands for present value, and R stands for discount or interest rate. I will explain discount rate here, but here we can say just interest rate. So for 1 year, the formula is like that. For T years, you can see in power T. And if we would like to find present value, simple math, nothing magical, future value divided by 1 plus R in power T. So now we will understand, we will know why we use present value. So guys, now you will understand why do we need discounted our money, why we need to find present value of all money. So again, imagine you're a rich, you're an investor and you would like to invest in oil pipeline project, and of course you have to start with investment. And for simplicity, let's say we have 3 years. In the first year, I indicate here year 0 because you just started your project and you invest 100 million manats. So it means that your cash flow is negative, right? There is no any cash inflow, there is cash outflow because you spent money, you invest money. So you invest 100 minus 100 million manats. So it means that your cash flow is minus 100 million manats in the year 0. So let's imagine for simplicity, all these steps, which is exploration, appraisal, and last one, development, happens in 1 year. So as we said, in these 3 years, you don't have any cash flow. Your cash flow will be negative because you just spent money. So let's imagine your project just started and now you are in production phase, you're in production steps, and this is your first year in production. Everything went well, and you earn 50 million manats from production. But in the second year, something happened, price decreased, or I don't know, maybe your expenditure increased. So that's why your cash flow will decrease to 30 million manats. Now you have to think about, should I go for this project or not? So this too actually is expected cash flow, your prediction, because you live your moment. You don't know future. This is your guess. You just research, you just search about petroleum market, you look at your competitors, you look at your expenditure, and you will understand that this is my probable, this is my expected cash flow in the first year of my production and the second year of my production, etc. So if you don't know about a present value, if you don't know about discounted of cash flow, what we'll do, we just simply add them up, right? Minus 100 million plus 50 plus 30, it will be minus 20 million manats. So it means that after 2 years, my net cash flow together will be minus 20 million manats. But this is wrong, guys. Just ignore this fact. This is wrong because it's not even fact, because we have to discount that our cash flow. What we said before, 50 million manats after 1 year is not the same amount now, or 30 million manats after 2 years is not the same money right now. So that's why we need to find present value of these two future values. They're future values, right? These values, this money is in the future, so that's why they're future values. For this, we need discount rate. So let's say, according to some research, you know that discount rate per year is 10%. So this is not the exact amount. We cannot say this is the exact discount rate. This is appropriate. This is near discount rate. So this is your best guess about what will happen in the future. Now we can use cash flow discounting or present value of cash flow, and then we can decide whether this project is economic or not. So for this, we need to discount it, or we need to find all present value of each cash flow. So cash flow in the first 0 year, let's say first year and second year. Actually, when you look at this math here, you will see that we don't need to find present value of year 0 because you live your moment. So present value and future value is the same for you in the first year. But if you want, you can just write. So you remember the formula, right? Let me show once again. So we are going to find each present value of each cash flows. So cash flow in year 0, so T is 0. Cash flow in year 1, T is 1, and cash flow in year 2, T is 2. So we can calculate here. This is our future value, or basically in our year 0, it's also our present value. So when you calculate, you can see that this is exactly minus 100. So as I said, if you want, you can write, but it doesn't mean anything. But we have to write first and second year because this is our real future values. So future value 50 divided by 1 plus 0.1, this 0.1 is discount rate. You can write 10% or just 0.1, they're the same. In power 1, it will be $45.46 million. And then if you look at the cash flow in year 2, we have to convert it to present value. So future value again, divided by 1 plus 0.1 in power 2, it will be 24.8. Now we can sum them up. When we sum them up, we can see it's approximately minus 30 million manats. But before this, we calculate if we don't care about present value, our loss will be minus 20 million manats. But when we discount it, when we find present value of each cash flow, it's more, minus 30 million manats. So this is the true amount. Of course, I ignore the fact inflation, deflation, other things, they are the risks. Here we just talk about the present value. And this amount is called net present value of a petroleum project. Net present value means that you have to find present value of all future cash flow, and then you have to sum them up. So we found all present values. We have 3 years, basically 2 years, we found it. And it will be minus 30 million manads, and this is net present value. So we have concept about net present value, whether we should go for this project or not, whether this project is economic or not. So probably logical when you say it's negative. If it's negative, it means that you don't need to start this project, because after 2 years you will end up minus 30 million manads. It's not beneficial for you. NPV concept, or net present value concept, says exactly the same thing. Your NPV, if more than 0, you accept projects. If your NPV is less than 0, you don't accept the projects. Like our example, we don't accept it. If NPV is 0, we're indifferent between accepting and not accepting the project. Like in our third offer, if you remember, let me show once again. Like in our third offer, you're indifferent because you will exactly get the same amount what you invested. So we have 3 petroleum projects here, as you see. Project 1, Project 2, Project 3. They're offered to you now. And you know that discount rate is 10%. Again, you make some research and you understand that, yeah, discount rate is 10%. So before starting, I would like to say how you can find appropriate discount rate. So as I said, there's not exact discount rate. So some people, some economists says that some people, some investors use discount rate as a rate of return, how much you will earn from your investment. Again, expectation. Some economists use the formula, so I don't want to give you this formula. This is a weighted average of cost of capital. So you need cost of your debt, cost of your equity, just huge process, but you have to know it exists. So people calculate discount rate with weighted average of cost of capital. And a third thing is about historical data. You just look at the history. You just would like to know whether there is similar project like yours, and you will see what was their cash flows, what was their expected discount rate. Then you can analyze and you can start your project. You can calculate your discount rate or your NPV. So let's take a look at our 3 projects now, Project 1, Project 2, and Project 3. So the first amount shows investment, your initial investment. Again, this is minus because you spend money, you don't earn anything. But you have 2 years here, 1 year and 2nd year. So first year cash flow is 120, the 2nd year cash flow 140. When you apply the formula, you have to calculate NPV. When you apply the formula, you will receive 25. So according to NPV concept, you have to accept this project because 25 is more than 0. Now let's take a look at the second project. Your investment is 339, so it's minus. Your cash flow in the first year is 100. Your cash flow in the 2nd year is 300. So your NPV is 0. According to your concept, you're indifferent because at the end, after 2 years, you will get 0. You will get nothing. So it means that you take your investment back. You will earn nothing. But if you look at the third one, we see that your investment is 600. So that's why it's minus 600. In the first year cash flow is 300, and the 2nd year cash flow is 350. So if we don't know about present value, what we will do? We just sum them up and we'll end up positive 50. If it's positive, we will say, yes, we have to accept this project because it's positive. But it's wrong. We have to care about present value. We have to calculate net present value. So according to calculation, our net present value will be minus 38, which is not positive 50. So it's less than 0. So we basically don't accept this project. You can easily calculate NPV in Excel, or you can write NPV calculator on the internet and you can find it, because as you know, in reality, production lasts longer, 30 years, 50 years. So you cannot calculate by your hand, right? So that's why you need Excel or you need NPV calculator. I would like to show Excel case, the third project. But there's this one trick in NPV, Excel you have to know. Just a minute. Yeah. So let's start from the beginning, step by step. You're an investor. You have 60 million, let's say $600 million for a petroleum project. So this is your initial investment. So but basically it took this year 0 because you just started. It's not future, it's now. And this is minus, we can write minus or just plus, doesn't matter. But it matters when we calculate NPV. So let's write 600 positive. You spent this money, this is your initial investment. Now we can write cash flow, year 1. According to our example, is 300. And cash flow in year 2, 300. So our discount rate, again, this is appropriate discount rate. You found it, you believe it's correct. It's 10%, or 0.1 you can write. Now you can find NPV here. Equal. When you write NPV, it will be here. You can see the steps here. Firstly, you have to write discount rate, which is 10%, comma, cash flow. Here you have to be careful because now we have to write future value, which is initial investment is not future value for us. This is present value. This is happening right now. So that's why we start with 300 here, comma, second cash flow, 350. You close the bracket, then minus your initial investment. If you write minus here, you have to write plus in formula. But I wrote plus here, so that's why I wrote here minus C1, minus initial investment, and then enter. As you see, what we found in our small diagram, it's minus 38. So in our case, it was manats, but here dollars, doesn't matter. I think you understand the concept. But again, if you don't like to work with Excel, but it's really important, you can do on the internet. You can just NPV calculator and you can follow the steps. You will calculate NPV. Okay, let's come back. I hope so far so good. Now we are going to look at other concept, which is IRR, or internal rate of return. Don't worry, it's not hard. Internal rate of return is a discount rate when NPV is 0. So you accept your project if internal rate of return is more than discount rate you found. If internal rate of return is less than discount rate you found, you don't accept the project. If both are the same, if internal rate of return exactly equals to discount rate you found, you're indifferent between accepting or not accepting. In our project 2, if you remember, our NPV was 0. So here it means that our IRR exactly the same discount rate, and we found discount rate is 10%, right? So it means that in the second project, our discount rate exactly is the IRR. internal rate of return. But let's imagine the same project but different discount rate. So it's not 10%. You do research, you look at the historical data and projects, you see that appropriate discount rate is 8%. Then you will accept the project because this discount rate, which is 8%, is less than 10%. So then you will accept this project. But you don't accept project if discount rate is 15% or just more than 10%, because 15% is more than 10 and discount rate is more than IRR, so you don't accept discount rate. Project. It means that here NPV will be negative. So from the beginning, we said if NPV is negative, we don't accept the project. The same idea. If discount rate, what you found, which is 15%, is more than IRR, you don't accept the project. But if discount rate is exactly the 10%, which is IRR, then you're indifferent because your NPV will be 0. So it's up to you. Maybe you will think, no, it's waste of time. I have to wait 2 years and I will get nothing. No, I don't accept this project. Or maybe you can think like that. Maybe I can contribute to petroleum economy. I can contribute to petroleum industry. So I'm going to accept. So it's up to you. We have small graph representation. Then I think you will understand better IRR concept and NPV. So in the left axis, y-axis, you can see NPV here until here, and in the x-axis you can see discount rate. Discount rate, you found it. So let's imagine you found discount rate which is 5%, and we can see NPV is 40, which is positive, so you accept the project. Or 10, NPV is still positive. This is just a graph, I think you understand me. Discount rate is 10, NPV is still positive, you accept the project. 15, yes, NPV is still positive, you accept the project. But when discount rate is 18.9%, then NPV will be 0, so you will be indifferent. Here, this 18.9, which we found as a discount rate, is exactly internal rate of return. And after this, which is beyond IRR, we don't accept the project because NPV will be negative. You see, right? When we go forward with the red line, we can see that NPV is negative. So here you can look at IRR and NPV, and you can make economic decision whether you accept the project or not. So guys, I think we have one last thing about risks. It's really important because not only present value of cash flow you have to care about, you have to care about other risks. So that's why risk analysis is really important. This is a process or procedure of identifying and evaluating some factors that it will negatively or adversely affect your success, your project success. So you have to care about these risks. You have to examine if you can avoid these risks, and then you can start your project. What kind of risk you can face? Geological risks, for example. Yeah, we said in the exploration phase and the exploration step, you have to do geological survey. But maybe your technology is not high enough, so here we can talk also of technological risk, but maybe it's not appropriate, it's not exact data. Or maybe, yeah, you found the petroleum in the land, and you're going to next step, which is appraisal exploration. You would like to know the potential reserve around it, but maybe you're wrong. Maybe there's no potential reserve. As I said before, there are two types of reserve: probable, proven, and potential. Proven is less risky. Proven means that you already proved that there is petroleum. Probable is more risky. You just think, you just predict. It's probable, it's not exactly. Potential, it's average risky. You say, yeah, if there's a petroleum here, this is geological area, There should be petroleum around here, but this is risky. You have to take care about this. In order to make good geological surveys, you know better than me, you have to have high technology, high skilled workers, etc. You have to look at the history and general research. And second thing is mostly economic risks, which is price risks, or we can say inflation, deflation. Inflation means the general price level increases, deflation means general price level decreases. So let's imagine you're planning to extract, I just give a number, I'm not professional for this. So let's say 100 million barrels, if I'm not if I don't give huge number or less number, I don't know, let's say 100 million barrels, you're thinking that, yes, I will extract this amount of petroleum in the next year. So you planned everything, you just calculate your cost, your sales, but suddenly in the next year, the price of oil, price of petroleum suddenly dropped out, suddenly decreased. What will happen? This is risky for you because you're already ready for your extraction. You spent money. You took many technological things, drills, wells, you hire many workers. You already spent money. You have to extract this petroleum. But when you extract, you have to sell this, but with a lower price. Because what you think about price was higher, but now price decreased and you have to sell with a lower price. So this is risky for you because your cash flow could be different than your expectation. So that's why I said cash flow in the future is just your expectation and you have to care about these risks as well. And the last one is environmental risks. I hope when you became investor, when you are dealing with petroleum projects, you have to care about the environment and you will care about the environment because we live in this world. If we don't care about the environment, we have two things. Let's take a side, we cannot produce petroleum once again, and the other social sides, we cannot live with dirty air, dirty environment. So that's why environmental risks are really important for your business and also for your life standard. So this is general risks. Actually, it's not limited. There are other risks. I just gave you some crucial risks. But now we can look at Dutch disease, which is related to petroleum, oil, and gas. So this is this disease. Why it's called Dutch disease? First, I'd like to say because it happened in Netherlands for the first time in 1960s, if I'm not mistaken. Yeah, it happened in Netherlands. That's why it's called the Dutch disease. So what's Dutch disease? Dutch disease says that a country discover an expansion of natural resource, but unfortunately, this abundant natural resource adversely or negatively affect the economy of a country. You can think how can happen if we have natural resource, how the economy can be worse. Let's take a look at this Dutch disease syndrome symptoms, then you will understand better. So firstly, a country becomes a natural abundant country by discovery of an energy field. For the first time, they're happy. They say, yeah, we will be rich because we have a natural resource and we can produce, we can export, and we will make a lot of money. So in the first time when they are happy, they say, yeah, we have to just focus on production of natural resource, let's say gas. It was gas in Netherlands. So they say, yeah, we have to attract more labor and more technology for this sector. So what will happen? Other sectors, service sector, manufacturer sectors, were out of the attention because as a government, as a country, you just give attention to petroleum or gas sector. You take labor and technology for this sector. And this will lead to high rate unemployment because the people who cannot work in petroleum sector, who can work in manufacturing sector, now they're unemployed. They don't have job because manufacturing sector were out of the attention. They don't have anything to do. So that's why it will lead to a high rate of unemployment. And as you know, unemployment will lead to a lot of things. It could be political instability, economic instability, which is really worse. And you will end up with low level of long-term economic performance when energy resources run out. As you know, gas, oil, their energy resource, they will run out one day. They will finish because they are non-renewable energies. And when you see this energy just run out, it will be hard for you to recover yourself because your manufacturing sector were not developed because you just didn't give attention to those sectors. So it will take time, it will take money and energy for you to recover yourself. But Netherlands survived from Dutch disease. Yeah, it took more than 20 years for Netherlands, but Netherlands then start pay attention to other sectors, and you know, Netherlands is one of the developed countries today. And according to research, that gas field will finish in 2020, 2000, I think, 28, if I'm not mistaken, and that's why they reduce their economic limit. They reduce their petroleum, gas extraction and production, and they give attention to other sectors. This is the best case for Dutch disease that they survived. But if you look at other cases, I can say Venezuela. Maybe you know already Venezuela case. You know, Venezuela is OPEC countries and big exporter of oil, and Venezuela's trade is mainly dependent on oil. They make money because of oil. But in 2014, suddenly oil price dropped, and it really negatively affected the economy of Venezuela because they already just thought about their extraction of oil, but now the price of oil is really less, but they have to sell it. But their expenditure, their cost was their benefit. So that's why it was really hurtful for their economy, and they faced with hyperinflation. Hyperinflation was more than 80,000%. Can you imagine? The price, general price level increased more than 80,000%. Now Venezuela should recover themselves, but it's not only about the economy. What I said before in the beginning of the webinar, petroleum is about not only mechanical power, also political power. So in Venezuela, there was a political instability about oil. So I think between government and some other social agencies. So I'm not familiar with Venezuela that much. I'm just interested in the economy side. So because of political instability and because of the drop of oil price, they face with low level of long-term and economic performance. And it's a kind of signal for them if their energy resources run out one day, what will happen to Venezuela? But now let's take a look at Azerbaijan case. As you know, Azerbaijan is oil abundant country, oil and gas abundant country. We also kind of dependent on oil because our main export is oil. And as you see, our energy consumption mainly comes from oil and gas. But what will happen to us when oil will finish one day? But actually, we can see kind of successful story if you compare Venezuela case and Azerbaijan case. Azerbaijan case is a successful story in Dutch disease. Why? Because Azerbaijan diversifies its economy. Diversification means that we care about other sectors as well. In Azerbaijan, especially, service sector is going to increase. If you look at from 2015, we have such games, European games, I don't know, Eurovision, other international games, that tourism sector is kind of increased. If I'm not mistaken, when I was in a bachelor's degree, I heard about the roadmap in Azerbaijan. Roadmap means how we can diversify the economy. We cannot rely on petroleum, just petroleum. So diversification is the main thing about avoiding Dutch disease. But of course, we have to care about our petroleum because we earn from petroleum. But it's really important, the next thing, that how we spend our money which comes from petroleum. For example, in Norway case, not Netherlands, Norway case, Norway avoid Dutch disease. Norway had some gas and gas fields, if I'm not mistaken, and Norway spent their money which comes from natural resource wisely. They invest in education. They pay back their debt to foreign countries. So this all are really important steps. So that's why, again, I don't say we have to just shut down petroleum things, petroleum sites. We have to care about the service sector, financial sector. We have to care about our petroleum. That yeah, we have to make good choice about investment, and then what we earn from money from this oil and gas sectors, how we spend our money. Again, education is really important for the economy. We have to care about education. We have to care about health of people and other things. We have to reduce our dependency of oil. So guys, from me, in a nutshell, I can say petroleum is really important and this kind of central power in our economy and in the world, but we have to care about to use petroleum projects, petroleum business and economics. So I hope when you decide to go for petroleum business, you have to care about some economic decisions. This is not all, but this is the main crucial points for you. You have to take care risks, NPV, IRR, and etc. So that's all from me. Thank you. Do you have any questions or something? In addition, maybe you can add something. Maybe you can say something about petroleum economics or just petroleum industry, because I'm not involved in petroleum industry. I know something about it. So my specialty is economy, so I just talk about the economy side. But if you would like to add something, I'm really happy to hear it.
It was very interesting and informative session. Thank you very much for that. We are so pleased to take your time for us, and thank you again. And I'd like to ask participants to take a final photo to share in the social medias if they can open their cameras.
Great.
Let's open the cameras, guys. We are waiting.
You have to announce beforehand because girls should do hair or something.
No, it's just a photo. They don't need any.
Okay, guys.
Makeups.
You won't be visible that much. We're all just small, so don't worry.
Yeah, we will edit your photos in the Photoshop actually.
Oh, we have this option as well. Great.
Yeah. No one is interested.
No, we have several people here. I see familiar faces. That's great.
Okay, cheese. Zeynep, you are the photograph. Just let us know when you finished.
Yeah. I keep smiling.
Okay.
Great.
Thank you very much,
Zeynep.
teacher.
You're welcome. Thank you very much for your invitation. It was really great honor for me, and I hope the webinar was useful. If you have further questions, Diana has my email, so you can reach her and just ask questions.
Of course.
Yeah, of course, I can share your mail with the participants, and I want to say thank you to you again. And this was very great presentation and great information for us, and that's why we really appreciated the time that you spent with us. Thank you again.
It's my pleasure. Thank you very much once again.